Hey guys, today we're going to talk about how you know whether a chemical is an acid or a base. Here we've got vinegar and ammonia. We know they're an acid and a base because they're labeled, and you should know from class that vinegar is an acid and ammonia is a base. If they weren't labeled though, it can be tricky because they're both clear solutions. These particular ones, vinegar has a strong odor and ammonia has a strong odor, so we'd be able to tell these. But if we had clear odorless solutions, we have another way to tell if it's an acid or base. And this is called acid-base indicators. This is one. It's called phenolphthalein. I've abbreviated this jar PTN. Phenolphthalein is a classic indicator in first-year chemistry classes. It is clear in an acidic solution, and it turns pink in a pH range from 8 to 10. So right after we've become slightly basic. If we want to see those colors, what I can do is I've got a couple of small test tubes. So here's a small test tube. So put a bunch of vinegar in this one. And then this other test tube, I'll put a bunch of ammonia. Right. So now when I take this indicator, I'm going to put one drop in either one. So inside the vinegar, shake it up, and it didn't change the color at all. It's perfectly clear. In the ammonia, in the base, we say that this turns a bright pink, right? It's a really dark, beautiful magenta color that a lot of people love to see in chemistry class. So that is a dark pink, right? This is a pH of probably about an 11 or so. This is quite basic. All right, so what else can we do with this? Instead of saying, yes, it's an acid or yes, it's a base, we can use the indicators to let us know when something has gone from being acidic to basic. We have a lab called a titration lab where we can take a look at finding out the concentrations. Now I'm pretty confident I know the concentration of vinegar has to be a certain amount of acid, but we can just neutralize it using this indicator. I'm going to count the drops of vinegar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now we assume these drops are all about the same size. So 10 drops of vinegar and 2 drops of phenolphthalein. Again, it's colorless. Why is it colorless? It's colorless because it's an acid. The pH is below 8, so it's colorless. The idea then is how many drops of ammonia will it take to make this solution go pink? When it goes pink, it's going to be at a pH of an 8, which is just past that neutralization, that equivalence point here. Right? So this is ammonia. I'm going to count the drops till it goes pink. Let's see. Put that one back in the beaker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nothing yet. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Might have had an extra one slip in there. 21, 22, 23, 24, 25. 26, 7, 8, 9. 30. 31, 2, 3, 4, 5. It's 35 drops. Oh my goodness. 36, 37, 38, 39, 40. Still clear. 41, 42, 43, 44, 45. Oh, it's almost turning pink on us. 46, 47, 48, 49, 50. You want to zoom in on this test tube? Come on in. 51, 52, 53, 54, 55, 56, 57, 58. All right, I'm going to bring a little whiteboard up here. All right, I mean, you can kind of come in a little closer. All right, so you see this. It should be very, very faintly pink, right? And so it's hard to see. This is really dilute because it's one drop inside that whole test tube. But this is right when we've turned to that pink side. You can see it really a little bit closer on the just the top part of that meniscus there. We can see that pink color. Can you see it at all on the camera? Okay. And that's good. What was that 55 drop? So next up, we will take a look at how to do the math to see what the concentration of the ammonia was. All right, so here we go. All right, so we have this question. What was the molarity of the ammonia in this demonstration? The ammonia is a bit of an older bottle I have here, and the vinegar is a pretty new bottle. So we can feel pretty confident that the vinegar is still the original concentration. We have an equation for a titration that the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. So now what values do we know? It's pretty standard that this 5% solution of vinegar has a molarity of 0.83 molar. And the volume of the acid we used was 10 drops. The molarity of the base is our unknown, and the volume of the base we found during our demonstration. It took actually 58 drops. So here we're using the number of drops of our solution as the volume. It's assuming that all the drops are equal. It's assuming a drop of vinegar is the same size as a drop of ammonia. So let's go ahead. It should be a pretty accurate calculation. But so what we're going to do now is we're going to rearrange this equation to solve for MB. So we will divide both sides by VB. These will cancel out. And if I just flip this around, we get the molarity of the base is equal to molarity of the acid times the volume of the acid divided by the volume of the base. Now we can substitute in our values and our units. And then we can go ahead and find our answer in the calculator. All right, so we bring our calculator in, and we're going to type in 0.83 times 10 drops divided by 58 drops. And our calculator is going to do the order of operations just fine. We get a number of 0.14310, and we're going to round this to an appropriate number of significant figures. We had 2 in the molarity. We had exactly 10 drops and 58 drops, so our answer should be to 2 significant figures. We're going to round the 3 down and keep this as 0.14 molar. And that would be the molarity of our base, the ammonia. All right, so that's it. We have a pretty easy formula, an equation we can use to find the molarity of an unknown acid or base. Pretty simple lab, just be a little bit more complex if we had burettes and we could do in person. But there you have it. Thanks for watching. Bye.